Hey guys, welcome to the first lesson of Unit 3. I know that this says Unit 3, Section 4. I forgot to change this. What this is going to be is, we're going to change that up. This should be Unit 3B, Lesson or Section 1. Okay, so this is the second unit. We have theorems, postulates, and corollaries. Oh my, if you recognize that quote, I'd be very impressed. So this is base angles theorem. What we're specifically talking about in this lesson is isosceles and equilateral triangles. Remember, an isosceles triangle is a triangle that has two sides the same, and an equilateral triangle has all three sides that are the same. So the base angles theorem states that if two sides of a triangle are congruent, then the angles opposite of them are congruent. So this is basically, it applies to any given isosceles triangle. The fact that these two sides are congruent forces this angle here, opposite of that, and this angle here, opposite of that, to also be congruent. So that's why AB and AC are congruent, therefore B and C are congruent. So here's an example. If HG is congruent to HK, so let's go ahead and fill that in, HG, HK, then blank is congruent to blank. So what we're going to say for this one, what are the angles opposite? So draw your little arrow. Looks like K and G. Angle K is congruent with angle G. The next one says if HK is congruent with KJ. So let's erase our marks from before. HK is this one, and KJ is this one. What you can think of for this one is if you were to tilt your iPad upside down, you might get a better visual, but it's actually this angle over here and this angle over here. So if we want to be specific with this one, and I should have been more specific before, I shouldn't have just said K. The first angle, this one up here, is KHJ, H being our vertex, and then this one down here is KJH. All right, let's keep going. The converse of the base angles theorem is that if two angles of triangles are congruent, converse, remember, is where we switch the if and then statement. So if two angles of triangles are congruent, then the sides opposite of them are congruent. So if we know that B and C are the same, we know that this side and this side have to be the same as well. So if two of the angles are the same, you can actually guarantee you have an isosceles triangle too. So let's apply this. So if G is congruent to J, I say so way too much, I apologize. If G is congruent to J, what are the sides that are opposite of those? We actually have to go all the way across. So that would mean that let me change my color here. FJ is congruent with the side opposite over here is going to be FG or GF. Those are congruent. Then it says if FHI, so angle FHI, which is this one here, is congruent with FIH, this angle right here, now what sides are we looking at? So let me erase these. We would be looking at this side and this side. So that would be FH is congruent with FI. So some logical conclusions from the base angles theorem and the converse is what's called the equilateral corollary. And we've already talked about this one before without even realizing it, but if a triangle is equilateral, then it is equiangular. The idea is if all of those sides are the same, it forces the triangle in such a way that all of the angles are also the same. And the converse of that is if a triangle is equiangular, it has to be equilateral. So these are all, go back here, 60 degrees, because remember, if we take 180 divided by 3 of the same angles, we would get 60. And then same thing for this one. If these are all 60, we know that all of the sides are the same. The sides don't have to be a specific measurement, but they do have to be the same. So let's do some application of what we've talked about here. So we want to find the measurement of angle X and angle Z. Notice that we have an isosceles triangle. We know that XY is congruent to YZ. You don't have to write this, but so if those two are congruent, we have an isosceles triangle. Therefore, we know that the angles opposite of them, X and Z, are also congruent. It's supposed to be an angle. So we have to find those angle measures. If this is 50, well, it forces these two to be the exact same thing. So we could call this X if we wanted to, but the trick is, well, 50 is not the same as the other two. So what we can do is take 180, subtract 50, we get 130, and then if we cut that in half, since the other two angles are the same, we would get our final answer, which is 65. So they're both 65 degrees. And we can write that here. If we want to write it separately, next one, find the value of X and Y. So if we look at the KNL, that is an equal angular triangle, which also means it's equilateral. So it's actually easier to start with Y on this one. These are all the same. So 4 is one side, Y is another side, therefore Y equals 4. If we look at this triangle over here, these two angles are the same, N and M, which forces these two sides here to be the same. If I do two, well, we don't actually have to do two tick marks. We can just do one for each. That means that this angle, or this side here, is the same as this side, so we can set these two pieces equal to each other. Subtract 1, and we get X equals 3. Y equals 4, X equals 3. Those are our answers on that one. I think this is our last, yeah, this is the last one here. Find the perimeter of the triangle. Remember that perimeter, well, we'll get to that in a second. Let's start by finding X first. We have X plus 4, we have 4X plus 1, and we know that these two angles down here are the same. Therefore, the sides across from them, we draw our arrows, that helps, are also the same. So let's do X plus 4 equals 4X plus 1. We got to solve for X, so I'm going to move this X over here, and I'm going to move this 1 over here. We get, those go away, 4 minus 1 is 3. These go away, 4 minus 1 is also 3X. Divide by 3, we get X equals 1. Now, if we want to find the perimeter, we need to plug this back in. It's easiest to plug it in over here. 1 plus 4 equals 5. And since these are the same, we know that this is also going to be 5. Lastly, perimeter is the outside of the triangle, so we need to add up all the sides. 5, 5, and 7. And we get 17 feet. Okay, that is it for this video. Go ahead and submit your notes for this one because we're going to do workbook problems for our practice on this.